All right, chemistry, we're going to go ahead and spend some time reviewing for our test. Today is part one, so we're going to go over one part of each section in your review. So some of these are found in your review, some of them are not. However, we're still doing the same processes for each group. So first group, number one, convert the following word equation into a formula equation, but do not balance. So we only have to write the words into a formula. So what's happening is we have aluminum chlorate plus barium sulfate yields aluminum sulfate plus barium chlorate. So when we go through and we do the formula equation, we look at our periodic table and we also look at our ions chart. Those are also posted in Teams if you want to go and find that document if you don't have it already. So when we go through, we have to first find the chemical symbol on the periodic table. So we know aluminum is Al. You also have to look at the charge since we're in a compound here. So aluminum has a charge of +3. Chlorate has a charge of -1, and that's found on your ions chart. So do these balance? You should have said no, because this is a 3 charge and this is a -1. So what should you do to balance it out? Well, you need to multiply this one by 3. So that tells me that's going to be the subscript of chlorate. So aluminum, there's going to be 1. Chlorate, there's going to be 3 of them. So we move on to the same process for barium sulfate. Barium, Ba, has a +2 charge. Now we look at sulfates on our ions chart. SO4, and it has a charge of -2. Do those balance out? Yes, so there should be 1 of each. So keep moving on. Aluminum sulfate now. So aluminum, we already know from earlier that the charge is +3. Sulfate, here we go. SO4, -2. So let me rewrite that so you can see it better. SO4, -2. So now we have to look at those charges. They do not balance out. So the most common factor that they can get to is 6. So I have to multiply this by 2. That tells me what's going to be the subscript of aluminum. And multiply sulfate by 3. And that tells me what that subscript is going to be. So hopefully this is jogging your memory of what we did before we left. So next, barium, we know +2 charge, and chlorate has a -1. So again, those do not balance out. This is a -1 charge, and that's 2. So we have to multiply this one by 2. That's going to be my subscript. So when we bring down and we write down our final answer, these now balance out. So I have 1 aluminum, 3 chlorate. I have a 2 and a 2, so those balance out. So it's BaSO4. Next, aluminum sulfate. So aluminum I had to multiply by 2 to get the charge to equal out, and SO4 I had to multiply by 3 to get the charge to balance out. Last part, barium, Ba +2, and we multiplied chlorate by 2 to balance those charges out. So that's my subscript. Just remember, compounds, you always look at the periodic table, find their charge, and then try to balance them out. Next, what you do is you go ahead and look to see if the individual element is found naturally as a monatomic or diatomic. So in this case, we didn't have any of those, but make sure you keep an eye out for that. Moving on, balancing the following formula equation. So we're going to practice balancing this out. So what we always do, write down your compounds. We got a Cr and we have oxygen. So now on the left-hand side, we have 1 Cr. On the right side, we have 2. The left, we have 2 oxygen. And the product side, we have 3. So let's go through and balance these out. So we know we need 2 Cr. So let's go through and do that. 2 Cr. So when I put a 2 there, that changes this to 2 now. Next step is this does not balance out. So we have to go back through and change all of this because we know we can get this to a common number of 6. So you go ahead and what would you multiply this by to get it to 6? You would do 3. So I'd put a 3 in here. That changes oxygen to 6. And now to change this oxygen to 6, I have to put a 2 here. But now we ran into a problem. This 2 changes chromium to 4. So now this is no longer balanced out. So last step is, what do I need to put here? I need to change that to a 4. So when I go through, and now I check to see I have 4 of these and 6 oxygen. So I'm balanced out. Okay, next we are moving on to, and you can pause this at any moment to review, but we're going to keep moving on. So number 3, change the following word into a formula equation and then balance. So the previous 2 steps we just did, now we're just combining them. So when we go through this, we have this equation right here. So iron 3 carbonate plus cesium to yield cesium carbonate and iron. So again, what we do is we go through, we write down their charges so we know how to write the formula equation, then we balance. So iron, periodic table, Fe can be different things. This tells me it's going to be a charge of 3. Carbonate on your ions chart is CO3 and it has a -2 charge. Cesium, find it on periodic table. Is it monatomic or diatomic? Because it's just an element by itself. And you would have said it's monatomic. Next, moving on, cesium. Now we got to look at the periodic table. It has a +1 charge because it is a compound now. So that's why you got to check the charge. Carbonate. We already know carbonate is CO3 with a -2 charge because we already found it on our chart. Last one, iron, Fe. Is that monatomic or diatomic? So you should have said it's monatomic. So there's only one of them. Next, we got to balance the charges out. These do not balance. I have to multiply. So pause right now and see if you can figure out what the formula equation would be. So you should have known that I need to multiply this by 2, multiply by this by 3, because the only way I can balance these is if they get to a common number of 6. So now I'm going to write Fe2 CO3 3 plus cesium. And that yields +1 and a -2 charge. So I need 2 of these. So I should put CS2 CO3. And there's just one of those. And lastly, plus iron. Now we did our formula equation. Let's add these lines in and go ahead and balance this one. So what you do is now I'm going to write down all the compounds. Does CO3 separate? No, so I can keep it together. And then CS. So I have 2 iron on the reactant side, 1 on the product. 3 carbonate on the reactant side and 1 in my product. Cesium, I have 1, and cesium over here, I have 2. So let's go through this. 2 on my reactant, 1 on my product. I can go ahead and put 2 there, and then this changes iron to 2. That's balanced. Awesome. What would make this balanced? Well, I got to put a 3 here, so I have 3 carbonates. That changes this to 3, but then it changes my cesium to a 6. So now the only thing I need to do is, hopefully got this right, I go ahead and change this to a 6 because that's how many I need of cesium. So formula equation is what we did, and then when we plugged in the numbers to balance it, that is finishing this problem. So great job. Okay, moving on to number 4, predict the products for the following reactions in words only. So you should already be able to tell that this magnesium carbonate is a special type of decomposition, meaning this is going to break up. Remember, if a body is decomposing or something is decomposing, it's breaking up. So it's coming apart. So magnesium carbonate, anytime you see this carbonate, this gets split up into an oxide and a carbon dioxide. So the metal, magnesium, the metal always stays with the oxide and a carbon dioxide is released. So make sure you review your decompositions, the special types. Again, anytime you see a metal with a carbonate, the metal joins with the oxygen and this breaks up and a carbon dioxide is released. So use these 1 through 4, pause in any problem that you need help with, and reach out to me if you need additional instruction. I will also be on Teams. All right, guys, have a great rest of your day.